So we're going to simulate an elastic collision where both sides are going to collide, equal mass trolleys, roughly the same speed. Okay, ready, set, go.
Mine was more.
Okay, actually what did we observe just then?
It was like elastic.
It was
inelastic.
It was more like inelastic, wasn't it?
Because it's
Alright.
always moving a bit faster.
Do I keep it?
Yeah, keep it going, keep it going. One more time. So actually this time what we'll try and do, we'll keep one stationary. So just put your finger there, Caleb. One stationary, and so when it gets closer, once you put your finger away, and as you send it off at an initial velocity. Not too fast. Again, what do we see? Inelastic. We're only getting inelastic collisions at this point. Okay? Alright, so that's alright, we'll have a look at that. That's alright, we'll have a look at that perspective. Yeah, turn it off. Alright, so we'll look at inelastic collision. We saw... Alright. So let's see if we can do a number calculation, alright, of that particular collision. Yep, so I'll get you guys to take a seat. We'll go through it. Sorry? Don't know, it looks like an assembly. Alright. So, equal masses. Alright, so we've got the situation where we had the cars were equal mass. So the mass of trolley A was the same as the mass of trolley B. Okay? Does that make sense? So let's call them, because they're equal masses, let's just say that for just representing our rule, they're both M. Okay? Now, we'll say this one over here was B, this one was A. What was the initial velocity of trolley B? This one that was situated there, that was 0. So we had 0 meters per second. Okay? Take a seat, Kai. And then the other one that was heading towards it, UA, let's say that was in some direction, in a positive direction, and this is where you need to state which one is positive, okay? So in the positive direction, we have maybe heading towards our right. We could say 5 meters per second. It was going a lot slower, but for this example, we'll say 5 meters per second. Okay? And then, because it was inelastic, what we observed, okay, not perfect inelastic collision, but reasonably close. They connected to it. They connected and then continued to move in the same direction, didn't they? Yep. So, how would we describe the final velocities? Final velocity A for an inelastic collision where they connect and move together in the same direction, we'll say it's equal to final velocity B. Okay? Does that make sense? That's when they connect and move together. So this is the condition that we need to consider for an inelastic collision, where they connect and move together. All right? So using that, let's simplify it and just call that V. All right? So using that information where we've got M, instead of not MA and MB, we've just got M, and instead of VA and VB, we've just got V. Let's apply that and our other values into the rule and see what we get so far. It's going to simplify it quite a lot. So we will have M of UA, which is 5. So we'll put 5M there, plus UB, which is 0. So 0 lots of m. So that term goes to 0. The second term, m of VA, which we're going to call just V. So we've got V times m, okay, plus, and again, another V times m, because VA and VB are the same. Okay? Everyone understand? Yep. So here these terms are the same, so we've got two of them. 2 V times m equals to 5m. Now, fortunately, what we've got here is that the masses are the same, aren't they? Because the masses are the same size, they're going to cancel out on both sides of the equation. All right? So 2v is equal to 5 meters per second. And the final velocity for that inelastic collision works out to be half. And it kind of makes sense because we observe when they collide and connected together, everything slowed down a lot. Yeah? Maybe not, and what we'll do with having the video tracker software on this setup, what we calculated is a drop in half the final velocity. I wonder, once we do some video analysis with the video tracker software, if we would actually observe a half drop in velocity in reality. Do you think it would be half, or do you think it would be less than a half in drop? Because it wasn't a perfect inelastic collision. Okay? All right. So